Okay, for this problem, we are trying to find the formula for f of x given the graph. Now, the key with this graph is we do have two unique points. We've got a minimum here at pi quarters negative 5.5, and we've got a midline value right at pi comma negative 4. So those are both really big helpful things to know in order to find all of the missing pieces. You can see in the text here the parameters laid out: A for amplitude or vertical stretch, and there's a B times the variable x, a plus C, and a plus D. So the C and the D have to do with translations. C is known as a phase shift. That's going to be your left and right maneuver there. And I actually prefer to write this in the following manner. So you'll see me kind of utilizing more parentheses than Kahn initially puts in their format. And that is to protect that C value as the true phase shift. If you don't, there's a little extra math you need to do to figure out phase shift given C, or vice versa. Okay, so I'm going to start with a couple of things here. So right in the middle, you could see this thing is oscillating up and down around the height of negative 4. So I'm just going to put that pink line there. It kind of helps me see points and values a little easier. But that value is the y value of this point at the midline is our d value. So minus 4 is the vertical shift down. Okay. The other part that we know about sine of x, I think I'll go back to purple for this. Sine normally passes through the midline and the y-axis, which is normally at the origin if there's no transformations. So let me just do a quick little sketch here. In your mind's eye, you're kind of keeping tabs on what a sine function should do based on what it does when it's not transformed. So sine function typically has, when we go through this, we track 5 anchor points. And they're either minimums, maximums, or midline. So sine function more or less looks like that. And what I keep my eyes peeled for is where is that midline point that normally starts right at the origin as sine is headed upwards. And so I see that behavior right here at the point they defined. And the key with that is it has been shifted to the right exactly pi units. Okay, so that is our shift, our phase shift, and I'm going to put that in there as minus pi. Remember, horizontal shifts, the signs are kind of counterintuitive. So if you're shifting to the right, you're taking it away. It's a compensating value for the shift to the right. In other words, if I put pi in for this thing, it would zero out this internal layer here and bring me back to the midline. Okay, the next piece has to do with, and I'm going to use blue here, has to do with the b value, and that is directly linked to period. So in this case, we're dealing with, well, nothing's labeled. It's just integers on the x-axis here. So I'm going to assume radians. So 2 pi divided by the period is how we calculate the b value. So the way you figure out period is you just count from, you could do it a couple different ways. You could grab a maximum here and go to the next maximum, or you can go from a minimum, like they gave us exactly a minimum to a midline, and that's exactly a quarter of the period. What I'm noticing here is this maximum does not appear to be at a nice integerial round number. So I'm going to use the exact values they gave us and just multiply that length from pi fourths to out to pi is a quarter of the overall. Okay, so somewhere out here, this gets back down to a minimum. So if we know a quarter of that period is the distance between pi fourths to pi, how far is that? Well, you could find that just by subtraction. So what does pi take away pi quarters? Use a little fraction math here. That's 4 pi fourths minus 1 pi fourth. That's going to be 3 pi fourths. Oops. 3 pi fourths. So that is the distance of a quarter of the period. So what you have to do to find the period overall is take that 3 pi fourths and multiply it by 4 of these things, okay? So multiply that by 4 and we'll get a period of 3 pi. So the period of 3 pi will allow us to calculate the b value with this little algorithm. So let's go back to this. B equals 2 pi divided by this 3 pi that we just found for the period. So we get a b value of, the pi's are going to reduce, we'll just get 2/3 for that. So 2/3 is the b value multiplier, and I would use parentheses. I know even though Con does not have parentheses in their format here, I've entered these kind of problems before with parentheses as I'm showing here in this clip, and it works just fine. All right, we are using the sine function because we kind of gauged this off of that midline point that shifted right. If we were doing it using a maximum point or minimum point, we could have used cosine, but we're going to keep it simple here. Okay, so the last thing we need to figure out is this a value. And I'm going to grab green for that one. Okay, so the amplitude is the distance from the midline to either the maximum or to the minimum. So now we're going to look at what is the difference between -4 and -5.5. And that'll easily tell us the amplitude that it function goes above or below the midline. So that is a distance of 1.5. Okay, so it goes 1.5 above and 1.5 below. And that is all you do for finding a. Don't worry about a positive or negative there. That would have to do with, is the function headed upwards through the midline at the point you were tracking, or was it headed downwards? And here, we're definitely using an upwards midline point. Okay, so now we have our model, and you could feel confident putting this in to the f of x blank there the way it is. You could also get rid of the parentheses inside. There's really no point to this. I feel like the function is much more user-friendly if you leave it this way here. But if you're a stickler for doing everything exactly like Con shows it, all you needed to do left to do is distribute that 2/3 through there. And you'll get this. So this is okay as well. I don't think it's quite as user-friendly as the first version, but either one will work. I hope that helped.